Oh, I'm audible. I can hear that. So what were we doing in the last class? Trimming. Okay. What is trimming? Mhm. Trimming is a process in which we remove some components from our engineering system and redistribute their functions to other components in the system or the super system. And when we talk of redistributing the functions, we only talk of useful functions. Harmful functions we actually want to eliminate. In fact, that is one of the criteria to identify which components to trim. So if there is a component that is causing a harmful function, that is a carrier of a harmful function, that is one of the first functions we want to remove. So trimming priority guide, we say that a function that is high cost but low value means overall functionality is lower. And we had done entire ranking in our function analysis to identify such components. So those are the components that we remove first. Then we look at components which are causing, which are carriers of harmful functions that we remove next. And then we said we also remove those components for whom we can have alternatives in the same system, and those alternatives can do that job. So what are the various rules of trimming? The first rule is we are able to trim a component when the object of the function is not there. If the object of the function is eliminated, the carrier of the function can be eliminated. That's the first. Then we can also trim a component if the object can self-serve, can do the function by itself. And the third way to remove a function, remove a component is that if some other component in my system can perform that same function. Now, how do we find this other component in the system? What do we look for? So another component that performs same or similar function on the object. So you only transfer the entire function to that component then. That is the first. Then another component performing a similar function on another object, on another component in the system. So since it is already performing the same function elsewhere, it can as well perform it here. Or another component which simply just touches the present object. Because it is touching the present object, whether there was a function between them or no function between them, there is already an interaction. I'm not creating something new. So again, I can transfer this particular function to that particular component. And we looked at the example of that paint filling system. So during the trimming process, where did we transfer the function to? We transferred the function of controlling the switch to the tank. We had the idea of a spring on which the tank would sit, and as the weight of the tank increases, the spring would press. We also had an idea of a pneumatic mechanism, where as the level of paint rises in the capillaries, it would compress the air inside the capillary or gas inside the capillary, and that would activate the switch. Are you with me? You remember? Any questions about trimming? Then we will come to radical trimming. Any questions about trimming? See, one thing to realize is that trimming, so while we are talking about these solutions from trimming, That is not the objective of trimming. The objective of trimming is to identify simpler, cheaper problems that you could now solve. Are you able to see this? A solution is something else. Solution, see, did you arrive at a solution through trimming? No. Through trimming, I only asked you, अच्छा अगर tank को control करना है, तो how will it control? Then somehow you already came up with these two answers also, which I had in my slides. I didn't tell you those answers, but you came up with similar answers somehow. But I did not take you through a process to arrive at that answer. So trimming is not a solution finding method. Trimming is only a problem redefinition or a problem identification method. Are you able to see this? The interest or the idea being that identify cheaper problems or identify problems that you can solve cheaply, quickly, and therefore get respite to the user, get a solution to the user faster. Is that okay? Any questions there? Problem? No. Trimming से तो मैंने खाली ये बताया, tank has to control the switch. Trimming led you to there. Beyond that, was there any guidance that I gave you? Was there any process that I gave? No, you came up with an answer. Now the problem, the answer was simple enough and therefore you came up with it there. So the first problem, that float is getting heavy, this is happening, that is happening, there is spillage happening. All that was simplified to how can the tank control the switch. That problem was simple enough for you to solve now. I did not lead you to a solution. That is all that I'm saying. The problem was simple enough now that you arrived at the solution. Trimming did not lead or give the solution to you. Trimming simplified the problem. That in itself might appear that trimming is a problem-solving tool. No, trimming is a problem identification tool. It simplifies the problem for you so that you can see alternatives. You can see how other resources can be used to solve the problem. Are you able to see this? So this is a confusion many people have, because when we're talking about trimming, we say a solution also. But in reality, trimming only simplified the problem for you. Then the solution became evident. That is what happened. Nothing else. Are you with me? Any other questions on trimming?
So in one sort of way will lead to trade-off, like between two solutions. For example, you are getting that let's take the example of that one. For example, if I got some problem with that tank, in that frame design, we will have to replace that old frame, but instead in simple assembled part, like there is tank. So if we can just remove that and we will have our own frame there.
Absolutely right. See, that is where the constraints of the problem have to be very well understood. जैसे जब when it was about the paint filling system, the user had already set a constraint that I do not want any sensors or complex machinery here. I do not want any electronics here. Find me a mechanical solution. So उसी तरह से you may have to put a constraint like I want easy serviceability. So as we move forward, we will also come to a place where we will learn how to compare and benchmark solutions. That will be after we do some solution finding methods. We are still only on the problem identification methods. This solution doesn't meet your requirements because we did not use a formal solution finding method yet. Are you able to see this?
So, this would be that comes to my mind is that would it lead to some sort of better efficiency as compared to pre-existing solution?
That is the entire objective of trimming. You want to have the entire functionality there with fewer components. With fewer components means that the cost of the system would reduce. Functionality remains same, cost reduce simply implies overall value increases. So now Pritha is leading me to today's lecture. Today we will talk about trimming for methods and processes. We'll talk about that in just a little while. But the rules for trimming that we have discussed until now are for products. We will now also discuss rules of trimming for processes. Is that okay? Can trimming depend on cost metrics and? Yes. See, we made the function model. We identified the cost of each component, or we had the cost of each component. We identified the functional value of each component. Did we not? So the first thing we did was remove those components which are high cost and low value. है ना? हमने देखा कि which components are easiest to remove. Those which are low value. Low value components are typically those which operate only on auxiliary functions. They were not basic functions. And that is where the difference between radical trimming and trimming is. In radical trimming, we actually go ahead and remove even basic functions. We say that carriers of basic functions can also be trimmed. So we trimmed even the pump which was acting on the paint. Do you realize that? So that is why it is called radical trimming. That you don't stop at only low value functions. You say, oh, any function, I'm ready to trim, provided I'm able to find an alternative. So it can include basic and high value components, and radical trimming can lead to really, जैसे हम कहते हैं ना, latent. When you work on latent MPVs, you can come to breakthrough results or breakthrough. So radical trimming can lead you there. Completely different way of implementing something. Wasn't the final solution of radical trimming so elegant and simple? Cost reduced, problems reduced, everything was so simpler and far superior, is it not? So that is the potential of radical trimming. Again, radical trimming did not give us the answer. It just took us to a point where we said that, how will paint move itself? We had to find an answer. But how will paint move itself? That was where we were left at. Are you with me? So there are solution finding tools which we could use to find the same solution. आप लोगों ने तुक्का मारा, someone worked out, someone said something, that was still hit and trial. We have not gone into that stage of solution finding yet. We are still in the stage of problem identification. But do you realize that we were able to come to a problem which led to an elegant, simple solution there? So radical trimming can help us do that. The rules for radical trimming are also the same as those for trimming, except that now you do not hesitate to remove high value or even components with basic functions. Is that okay? Any questions about that? So he's asking if there are multiple targets, will trimming help? Yes, it's just another function model, and there are different components performing basic functions, not just one component or not just one function.
Basic functions है, basic ranks है, उस पे वो depend करेगा.
I'm sorry?
Basic function है, basic need है उसका, तो और दूसरा भी basic need है, उस दोनों पे हम ला सकते हैं.
Yes, radical trimming can go on those components also which are carriers of basic functions. That is what radical trimming is about. Is that okay? So, looking at the exact, that was a visual thing, looking at the exact definitions here, what is important to realize is trimming is driven by a hierarchical set of rules. You first try rule A, then rule B, then rule C. That is the method to arrive at the most efficient answer. Are you with me? Then As we were just discussing, maximum value is achieved because you're removing extra components while maintaining the functionality. So surplus components are getting removed. New problem statements that point towards new impactful solutions. Again, trimming, I said, is a problem identification tool, not a solution finding tool. It only gives you new problem statements which can point towards impactful, more elegant solutions. And because you're starting with a function model and trying to see which other component can do the same function, it reveals value of those components which you would otherwise miss. So typically we look at components and we see what function those components are performing and we assume, okay, ye isliye hai. Trimming kind of very systematically pushes us to question those assumptions. So if you remember, when we were talking about creativity blocks and creativity boosters, we discussed that previous knowledge blocks creativity. That was one of the creativity blockers that we discussed. And trimming very subtly removes that block for you. Are you able to see that? Oh, this function, this component is used for this only. No, now you start to see, can I use it for that also? So it helps you dismantle that block for yourself. Are you able to relate it? So all of these, so Altshuler did not explain it in that manner. But since we have gone through these creativity boosters and blockers, we have reflected upon them, built those chains and diagrams ourselves, we know this is a block that we have, every one of us suffers from. And this is where it systematically breaks that. Okay? And the key terms that we use in trimming are trimming model. It is the model of the engineering system which would develop after trimming has been done. That is the trimming model. Okay? Trimming problem, it is the problem or the new problem that it has shown us which needs to be solved to make that trimming model work. Then trimming rules are those rules for eliminating components, function redistribution, we just discussed again, and similar functions is again a keyword, which means that functions with similar objects and or actions. Okay. Now we look at what Pritha was asking for. Can we do this for processes or methods or algorithms? Now, do you realize that to do trimming on products, we had to first make the function model of the product. Now, for processes, it is not called function model, it is called flow analysis. So flow analysis is what we will look at now. So what is flow analysis? Flow analysis, so function analysis for processes is an analytical tool that identifies and classifies functions of operations in a process. What is a process? A process is a sequence of actions on material objects. A technological process is a process that uses material objects such as raw material, labor, energy, information, data, and machinery to create finished products. Now, if you look at the last statement, it covers almost everything of your algorithms in it. Any algorithmic way that you are using to solve a problem, if you want to improve that algorithm, it points that that technological process can be improved or can be modeled as a flow. Are you able to see this? So it is not just, so while we will use examples of tangible flows and tangible products, because it is easier to understand in a class setting, if you are working on, say, some novel way of computer vision or anything, you could be working on, depending on which stream you're coming from, what kind of a project you are working on. You could be working on a wide range of algorithmic topics also. And in your BTP or MTP or PhD research, this kind of a method can actually be very helpful. Okay. So function analysis of processes builds and analyzes function model of the process. The model includes function contribution of each operation, its corresponding costs, function type, and performance. So you see there is a very strong parallel with product function analysis of product function modeling. वहां भी हमने कहा था we will have a cost associated with each component, everything we had talked about. Over here also we're talking about the same things. Then functions performed by different operations are compared and ranked by their functionality. Again, just like we said there that something that acts on the target, that is a basic function. We have a very similar definition. We would call them productive functions over here. So we'll come to that. So very similar. You'll see lots of parallels there. This information is used to identify operations for further improvement or for trimming based on the type and performance of functions. Okay. And the outcome is a function. Outcome of function analysis of processes is a function model of the process and a set of functional disadvantages which are used in subsequent stages of analysis and problem solving. But this was all blurb. Let's go and have a look at an example. Is that okay? Anything that you want to ask in this list as of now? Any question that you have over here as of now? यहाँ तक clear है? But now it is about processes, not products. We'll call it flow analysis. You will see the differences. Before I go to the differences, I want to ask if there is any question. I am myself telling you it is very similar. So we will probably be able to go faster over here. But there are differences. The methodology, the mindset has to be same. Okay. So let's take the example of reheat and blow process. How many of you have heard about this process? Reheat and blow process you've heard about. What is it?
Basically make like more just bellings
So we will take the example of how many of you drink water from a plastic bottle, say Bisleri bottle or Coke or Thumbs Up? सबने पिया है कभी ना कभी? So those bottles are made by this process. There is just a small pellet of plastic that you have. This is the size of the bottle. This is the bottle. Okay. And it is heated and it is, so see, यहाँ से raw material, छोटी-छोटी plastic pellets आती हैं, and it is heated and it is taken through a mold, and that results in a bottle that you have in your hand. Cap is handled differently, but the bottle is this is how it is built. Now the mold could be of different shapes, and since the mold could be of different shapes, you have different shapes of plastic bottles available with you. So we will look at this process. So what is done? So it is plastic pellets are plasticized in the injection molding machine, where plastic is melted by heat and the shearing action of the feed screw. This is the first step. Then creating of preforms. The plastic is injected into multiple cavity, taking the shape of long, thin tubes called parisons, including the necks and threads. Once the parisons are ready, these preforms are transported, and they are organized to be fed into a blow molding machine. जैसे यहाँ पे लगा रखी है, ठीक है? And then, so this small thing in there, so this small thing is the, so जो bottle है आपकी पहले ऐसे दिखती है. It's a small, this is what is called as a parison. It is put into the mold machine and closed from the top. And then it is heated. So mandrel fills the parison with highly pressurized air, and pressurized air, heat and pressure causes the preform to blow and stretch into the mold, taking the final shape of the bottle. Okay? You've blown bubbles. It's something like that. That photos aapne dala, and as you pressurize, put pressurized air in heat into it, it will expand. Balloon ki tarah, it just simply expands. And once that is done, you take this thing out, you cool it, the mold is cooled, and then you trim it. So trimming is not that function trimming. This trimming is, there would be some parts of plastic which would still remain, which would kind of, cause abrasion to you. आपने कभी किसी मोल्ड से अगर, actually the challenge is triple IT में we do not have those forging and other workshops, but if you have worked in a workshop ever, carpenter के पास भी कहीं पे भी आपने देखा हो, when there is a mold and you do something, at the corners where there is a gap, okay, there is an extra material that is left. So removing that extra material is what is being used as trimming over here. This is not that trimming. Okay. So we'll come to that trimming also, but this trimming is just kind of giving it the roughing up, smoothing its edges and cleaning up that extra material that could be there. So this is the process of making these bottles over there. What are the problems? First problem is haze and stress whitening. Haze develops when PET in it is heated beyond about 115 degrees Celsius. Okay? And allowed to cool down for a short time. This happens that PET molecules have enough freedom to form crystals at higher temperatures, and stress whitening happens when PET is overstretched, breaking its microstructure. This is caused with a thicker and colder wall as the inner part of the bottle expands more, and heated PET cannot fill these breaks. Okay? So this is about the chemical composition of the PET, that if it is heated above 115 degrees Celsius, the chemical composition or the decomposition that happens, due to that, the whitening of bottle can happen. So imagine drinking Thumbs Up or Coca-Cola, black colored fluid in a bottle which has these white coloring on it. You would think there's something wrong with the bottle. You will not purchase that bottle of Thumbs Up or Coca-Cola. So these bottles are rejects. We don't want rejects. Okay? And then the second problem over here is that the trimming के लिए मैंने कहा कि trimming जो है कई बार extra plastic चला जाता है, and a lot of trimming is required there. So that also takes time, because see, when you are trying to remove that extra material, it can always happen that you will make a hole in the bottle also. Something of what was needed can also get removed. So it's a risky process. It's a process again in which you start to see yield loss. So not a good thing to work with, and you want to somehow avoid this also. So just like function analysis of earlier, we have component analysis here and we have function modeling here. When we say component analysis, we're talking about operations constituting a process. Heating, cooling, all these are operations constituting a process which we would call as, say, injection molding. Or so हर जो भी हमने 7 steps बोले, उन 7 steps के अंदर, in each of those 7 steps, there was something more than one thing that was being done. For example, in that expansion process, you were injecting air, pressurized air, you were also heating it, And it was also taking shape of the mold there. You were also closing the mold and everything was happening. So every process has multiple steps in it, and those are modeled as components. Those operations are modeled as components there. Okay. And function modeling is that different operations of a process are identified and evaluated for their usefulness, harmfulness, type of function, value, cost, etc., etc. Okay. Exactly the same way as we did for products earlier. Here comes the difference. When it comes to types of functions, we had okay, useful and harmful. But after that, useful functions were split into additional, basic, additional, and auxiliary. In flow analysis or in function modeling for processes, the functions are called productive functions, providing functions, and corrective functions. We'll go into the definition of each of them. Providing functions are of three types. Those that are called supporting functions, transport functions, and measurement functions. All these three are providing functions. Okay? So, first is useful functions and harmful functions. This classification is fairly simple. Functions that contribute in the development of the product are useful functions. Useful functions are classified according to the changes that they bring about in the final product. Functions that introduce temporary or permanent defects in the product are harmful functions. Is that okay? Harmful functions are those functions that produce temporary or permanent defects in the final product. I already said productive functions, then providing functions are of three types: supportive, transport, and measurement, and corrective functions. So what are productive functions? Productive functions are useful functions that bring about irreversible changes in product parameters. The changes brought about this function are prominent and visible in the end product also. Okay. So productive functions are those functions whose impact or whose action is evident, that ये function हो गया है, is evident in the final product also. Okay. For example, to form a helmet. Now that's a productive function because after forming the helmet, the shape of the helmet is fixed. It is available to you in the end product also. Are you able to see this? Then, providing functions. Providing functions are those functions that help perform useful functions in the system. For example, and they can be of three types: supporting, transport, and measurement. And supporting function, example of supporting function. It's a type of providing function that temporarily changes the parameters of the product. For example, those of you who've done forging, क्या करते हो आप? आप पहले iron को heat करते हो. You heat iron. Once it becomes malleable, आप उसको hammer करते हो. Once it takes that shape, you cool it. When you look at the final iron shape, even this, do you know if it was heated? Now it is no longer hot. Because it is now no longer hot, that heating it is a supporting function. Are you able to see this? Are you able to see the importance of supporting functions? You do so many things during the process that help you to accomplish productive functions to happen. Now, hammering was a productive function because hammer kara tabhi wo shape ai. But heating was a supportive function. Is this clear? Then, transport functions are very easy to understand. We looked at that ball bearing example where the bearings were moved from one part of the factory to another part of the factory. So कुछ भी होगा, आपको कोई भी प्रोडक्ट कहीं से भी मूव करना है, तो that's a transport function. It again is a providing function. If you're not able to transport either raw materials or the product from where it is manufactured into a different place, you will not be able to do anything. Your entire assembly line will come to a halt. So because today things are happening in the assembly line, transport functions are defined as separate providing functions. You may not see the importance of it yet, but you will see the importance of it soon when we will talk about trimming. Okay? So transport functions have their interesting role and important role to play when we come to the next stages of flow analysis. And then measurement functions. This is clear. See, measurement functions have to be performed. You want to give this bottle this shape, or you want to keep the, turn the metal threads onto it so that each thread is just 1 millimeter thick or high. These measurements have to be done. If you do not measure, the system will go for a toss. Many of the students here are from the, doing VLSI courses. So if you do not measure what is the doping level, if you do not measure what is the thickness of the gate oxide, or you do not measure such things, your device will simply not work. So measurement functions. Now, do you ever, when you use a device, do you ever see that it was, the gate thickness was measured and verified? No. So there is no artifact of this measurement function evident on the final product. Therefore, it is also a providing function. But measurement functions are very, very important functions. They are used to ensure quality of products. If you do not do measurement functions, quality of the product is not assured. So measurement functions also are, and it's important to know that they are important functions because they are very costly. They can be very, very expensive. And a lot of innovation actually happens about in how to speed up these measurements. So measurement functions are very important functions. If we can trim them, they're also very costly. If we can trim them somehow, fantastic. But that activity of measurement, or that assurance that a measurement function gives, quality assurance that it ensures, has to be given in some way or the other. And then we look at the last type of functions, which are corrective functions. So जो हमने अभी बात करी bottle से extra plastic हटाने वाली, that is a corrective function. Something was done, there was some excess or something missing, you had to compensate for it, that is corrective function. Compensation or removal of extra material, both are corrective functions. Are you with me? So, any useful function directed at a defect, whether आप उसको बड़ा करना, आप उसको रिमूव करने के लिए कुछ कंपेंसेट कर रहे हो या उसको रिमूव करने के लिए कुछ एक्स्ट्रा हटा रहे हो, that is a corrective function. Now, this is how, see, we had this one table for writing functions for products. That table had things like what is the component name, what is the function, what is the object, whether it is a harmful function or a useful function, and what is the level of performance of the function. So we had a table for that. Similarly, these tables are all, the function model for processes also have first the operation in which the function happens, what kind of function it is, category of the function, type of the function, then level of performance. Again, normal, insufficient, or excessive, and cost. If you put all these for different functions in your system, you will have a complete functional analysis for processes available with you. We can use these codes, productive के लिए PRD, providing के लिए PRV, then measurement M, supporting S, transport T, and corrective के लिए C. This is a legend that you can use. You may decide to use a different legend, but we will use this legend to create or show the function model of the RBM process. Is that okay? So, injection molding, that is the operation. Function is plastic pellets are plasticized. Is it a useful function? Yes, definitely. Is it a productive function? Yes. After this function, the shape of the plastic bottles, the plastic pellets is no longer available to you. Previous shape is no longer available to you. What has happened? A new shape has emerged. So it's a productive function. And the level of performance, we say it's normal. Cost, high. A lot of heat is required in this process. Then creation of preforms, plastic injected into parasons, useful. But now a providing function. Those parasons, do you even know how a parason looks? A parason looks just like a test tube. It is just this big. That 2-liter bottle is just this big, like a test tube. Okay, it is thinner. It is thinner than the lid also. Okay, so you don't know it because it is a providing function. If you were able to see an artifact of parison in the final product, you would say this is a productive function. But here it is a providing function. And supportive kind of providing function. Then transportation of preforms, clearly a providing function of the transportation type. Then unscrambling the parisons, putting them onto those things, again a transport function. It is taking it from one place and putting it into a different machine. Transport function. Stretch blow molding. Blow and stretch the parison into the shape of the bottle. Productive function. Because that is the shape that you also see finally. Then cooling. Productive function. Because finally the bottles that you use are cool. They're not hot. Trimming. It's a corrective function. You do not see that trimming has been done. But trimming is done. So, cooling function. And because our problem was with the crystallization, that haziness that appears, we have said that the level of performance of this cooling is insufficient. This is where I have a problem. All other processes, still normal. You needed to heat that much because plasticize karna tha. Cooling में आपने ज़्यादा जल्दी cool कर दिया, because of which that whiteness appeared or something like that happened. So now we enter into, now we have a function model, and now we will look at how to trim this function model for the flows. Any questions until here? Is the process function model clear? So now we look at trimming for processes or for flows. So trimming for processes is an analytical tool for removing certain operations. See, पहले हम components कहते थे, अब हम operations की बात कर रहे हैं. Trimming certain operations from a process and redistributing their useful functions amongst the remaining operations of the process. Are you able to see this? So, how to identify operations for trimming? So, just like हमने कहा था कि functions which have key disadvantage, components which are leading to functions of key disadvantages, those should be trimmed. Here also we are saying cause-effect chain analysis is a way. We had said that functions or components which have high cost but low functionality, low value, or so they are low value function, the components, they should be trimmed. That is also what we do over here. So functions have a cost, and if they have, if they are not productive functions, for example, they should be trimmed. So the same rules apply here. But now we look at it as operations of trimming can also be selected based on types of functions they perform. The relative importance of operations is as follows. वहां पे हमने कहा था basic is the highest. Why? Because basic functions were acting on the target. यहाँ पे we are saying productive functions are of the highest value. We can do the same ranking. Productive functions, because their artifact is evident in the final product. They are of highest value. Then operation with a supporting function. Supporting function is needed ताकि आपके productive function की cost minimal रहे. They are like catalysts. So supporting functions also should be trimmed. Supporting functions have high value. Then transport functions. You have to move stuff from one place to another. Transport functions also important. Lowest value is for corrective. Lowest is for corrective. Because you do not want there to be any defects in the first place. If you improve the earlier functions, there will be no defects, so corrective functions will not be required. So corrective functions should be the first target. Then measurement functions, if you can somehow do away with the measurements, while still maintaining the same quality, the same output. Because measurement functions are also very expensive. So, how do we do the trimming? An operation with a productive function can be trimmed if the object of the analyzed function is eliminated from the system. The necessity to perform the analyzed function is eliminated. So you wanted a particular shape, but if that shape is no longer required, do you need to do that heating now? No. So the necessity to perform the analyzed function is eliminated. And the analyzed function is transferred to the preceding or subsequent operation. You see the very similar rules as product in the trimming. Very, very similar. You can actually see the parallels there. Then, trimming rules for supporting functions, again ranked in the order of hierarchy. Operations require the supporting function is trimmed. भाई अगर मुझे forge करना ही नहीं है अब तो मैं heat क्यों करूंगा? That supporting function can be trimmed. The supporting function is changed so that it does not require any support now. So suppose instead of forging, I start to do sheet metal. That's a different way, or I start to do 3D printing. That's a different way of creating the product. Now what do I need to do? Now I clearly do not need the function of heating or forging or whatever. The supported operation performs the supporting function itself. And the analyzed supporting function is transferred to the preceding or subsequent operation. Very similar rules again. Is this clear? Just definitions. We will look at an example in just a little while. Then, a transport function can be trimmed if the object of the analyzed function is eliminated from the system. The components between which the object of an analyzed function moves are eliminated from the system. अब दो components हैं ही नहीं, एक ही component में सारा काम हो रहा है तो transportation ही नहीं बचा. The subsequent operations are changed in such a way that the necessity to perform the analyzed function is eliminated. ठीक है? Or analyzed function is transferred to the preceding or subsequent operation. For measurement, how do you trim a measurement function? A measurement function is needed as the final output. The operation is trimmed according to the conditions that exist for the productive function. If the measurement function is needed for the provision of another operation, the operation is trimmed according to the conditions existing for the supporting function. Now, example, यहाँ पे slide में नहीं दिया हो, but I will give you an example, very interesting example, how one of the measurement functions was trimmed. So, they wanted to heat needles to a particular temperature and then drop them into water, or they wanted to cool them to a particular temperature and then drop them into water so that the strength of the needles would remain same. Okay? So they chose the material of the needles in such a manner that it had a Curie point. You know what is Curie point? How many of you do not know Curie point? Okay. Curie point is the temperature at which the magnetic properties of a substance change. It can be magnetic above it, or it can lose magnetism above that temperature. So Curie point के ऊपर जाते ही आपका magnetic properties are lost. So आपको needles को heat करना है to a particular temperature, and only after that you put them in water. Okay. So till then, so they were made of a material which had a Curie point of that temperature. Let us say 78 degrees Celsius. So they made it of an alloy which had a Curie point of 70 degrees Celsius. Till then they were magnets. So they were till the temperature of the needles was 70 degrees, they were magnetically connected to the heater, which was a magnet. Okay? As soon as the temperature increased or touched 70, the needles lost their magnetism. They fell into the water below. Now they were given the exact treatment that was needed. Earlier, what was required to be done? In the earlier process, the heating would be happening through some method, and there was always a temperature that would be measured. And कभी 71 degree पे आप उसको quench कर रहे हो, कभी 70 degree पे, कभी 69 degree पे. So there was always this variation. But now, by using a scientific principle of Curie point, Curie temperature, the need was eliminated in itself. So the measurement is no longer required. Are you able to see this? So we have to think of ways in which that, for example, you want to see what is the width of your some part that you have made. Okay. You want that width to be lesser than something. So either you can measure that with a scale for every part, or you can say that a part will pass through this gate only if its width is less than that. Now, is measurement required? No. So if you've modified the component in such a way, if you modified the process in such a way that measurement is no longer needed, that is how you will trim measurement functions. Okay. And corrective functions. We said we want to remove the corrective functions altogether. A long list, a very long list. If the operation that generated the defect is eliminated, corrective function is not required. Defect ही नहीं डाल रहा. If the operation that generates the defect is changed in such a way that it does not generate the defect any longer, again the corrective function is not needed. The operation that generates the defect is changed in such a way that it starts generating a defect with another safe set of parameters. So, see, suppose you are making some glass, okay? And in that glass, the strength of the glass depends on the size of air bubbles that could be there in it. So until the air bubbles are smaller than 2 millimeters, there's no issue. Once the air bubbles are bigger than 2 millimeters, the strength of the material degrades. So it's a defect. So if you can change, so पहली बात हमने कही, change the process in such a way that air bubbles don't appear. अब हम कह रहे हैं, change the process in such a way that air bubbles, even if they appear, are lesser than or smaller than 2 millimeters in diameter. Are you able to see the distinction between these two rules? So there is always a safe set of parameters in which a defect can appear. And you change the process in such a way that it remains within that safe limit. You don't need a corrective function. Then, operations which are harmed by this defect, if those operations are eliminated, again the corrective function is not required. Now let us say this glass that we were making was required to be strong because after this glass was manufactured, it was to be, let us say, pressed pressed for 2 minutes in a different setting in a different machine after a transport function. Now, if instead of press-based attaching, you use a glue. If you use a glue, now even if there are defects, air bubbles bigger than 2 millimeters, the strength is not no longer required. Because अब आपको प्रेस करके नहीं वो करना है, आप glue से कर रहे हो, अटैच कर रहे हो दो objects को. Are you able to see this? So that is what this particular rule means. And then a corrective function is transferred from that operation to the operation producing the defect. So जो ऑपरेशन डिफेक्ट प्रोड्यूस कर रहा था वो ही उसको करेक्ट भी कर दे रहा है. ओके, और द एनालाइज करेक्टिव फंक्शन इज transferred to the preceding or the subsequent operation. So again, that corrective function, that time that you require for correction is no longer needed. It will be taken care of in the preceding or the subsequent function. Okay? And this is how you would do the value analysis of the RBM process, where we say that trimming has low functional significance because it's a corrective function, but the cost is high. Injection molding, heating, productive function, so high functional significance, but cost is also high. So it's somewhere here. Stretch blow molding, productive, so high thing, and also heating is required, so cost is high. Cooling, high functional significance because it's a productive function, but cost is low. No energy required now. Cooling ही तो कर रहे हैं. Creation of preforms or partisans, very less heat required. So again, it's a kind of low cost, but productive or providing function, supportive function. Transportation and scrambling, they are low cost and low value also. So they are here. And now we have to look at which function is causing the problem. The problem causing function was cooling. What do we do about it? So, for example, those in so we have all these functions put in the various quadrants, and now we apply the trimming rule B for operations with a corrective function. So what is the rule B? An operation with a corrective function can be trimmed if the operation that generates the defect is changed in such a way that the defect is not generated any longer. Transfer to the productive function of improving the cooling. The function to cool the mold faster or decrease plastic injection temperature to prevent flashing. So या तो आप 115 डिग्री के ऊपर molding ही मत करो, don't take the temperature above 115 degrees Celsius, or you cool at a different rate ताकि crystallization हो ही ना पाए. Because white haze comes because of crystallization happening. If you cool it very, very quickly, it will not happen. So somehow you want to do that. Just give me a second. हेलो हेलो, हाँ मैं अभी क्लास में हूँ, तुम टैक्सी बुक कराते हो, मैं बस 2 मिनट में खत्म कर रहा हूँ. चलो. So am I audible? Yeah. So if we can somehow give the task of cooling also to the productive function, we will be able to avoid the corrective function there. Are you with me? So what do you do? Over here, see, अभी क्या है, अभी cooling के लिए जो mold cavity है उसके साथ से cooling channel ले जाया जाता है. And do you realize that this cooling channel is farther away from some part of the mold and closer to the remaining part? So that farther away part is where the cooling will happen slower, and which is causing the flashing part of it. If I change the channel in this manner, it will quickly cool the entire mold in one go. So the corrective function is eliminated. It is no longer needed because defect ही नहीं आ रहा है. Are you able to see this? So if you change the, so this was something, the choice of mold material also makes massive difference. So it was not just the shape of this channel through which the coolant was being passed, but even the material of the mold. If it is more thermal conductive, it will dissipate the heat into the coolant much faster. So both the shape of the cooling channel and the material of the mold are changed so that this flashing doesn't happen. Two things done to avoid flashing. Are you able to see this? So now what has happened is that your entire channel is now running close to the mold and it cools the entire plastic bottle quickly in one go. Any questions?
So I had some question regarding those productive functions. Also, in most productive functions, the functions which contains the which relates to like various processes. For example, how the product is going to look. Like it may include design, it may include paint, what was
Yeah.
so how they are the most important function in that context. Because at the end of the day, we are talking about just appearance. While the other
So see, it is something like this. Finally, product जो है वो जैसा दिख रहा है, that is how people identify it. Again, just like I said for product function modeling, that when I have said that basic function को highest rate दो, that is just a simplification. You can use MPVs to do a better function modeling. The same is applicable here. I've just given you an example here. It is a simple example. This is one way of doing it. You may say that, okay, even my productive functions I will rank separately based on whether this, so productive function is not just about how it looks. Productive function could be about what is the strength of my material. There can be many reasons of why a function is called productive function. And you can further rank them accordingly by using the MPVs. So the same thing that I had told about product function modeling is applicable here also. Is that okay? So that's a very genuine doubt because how can everything that is just leading to a final product be equally important? No, it is not. That is where your MPV discussion that we had before comes into picture. So you will see we're always building upon what we have discussed earlier. If you had missed that session on MPV, today you will be scratching your head, what was MPV? So you can still go back and look at the recording of the lecture on my YouTube channel. But yeah, so you have to be regular to be able to make sense of what is being talked about over here. Otherwise, you're learning a new language and everything will get jumbled up for you. Is that okay? So we'll close the session, Abhi. We will continue with function flow analysis in the next class also. I would suggest that if you have, so this time was already allocated for this class. So I would suggest that if you have your team members here, sit together, work on your project. Do the function modeling. Now, those of you who had process-based product projects also, we've done function modeling for processes also. So you can also do it now. So please utilize this time. You will not even realize how quickly time will fly. And we will come to a stage when you have to make your final presentations. So please utilize this time to work on the processes, get the questions, and in the next class when we meet, you can always ask me those questions and we can work on those. Okay? All the best.